So we'll start with the test of significance. In different condition, which statistical test should be utilized? That is the topic today. Let us first take a one Excel file, take various example, and let us make a flow chart. So what we will be discussing in initially few minutes, that in a particular situation, which test of significance should be used. Test of significance means if there is a given situation or given example, we need to find out whether the event has taken place because of some reason, or it can have happened just by chance. That is why we are using test of significance. While we are using statistics, we are talking about probabilities and not the fundamental answers like yes or no, but probability that it could be yes or probability that this could be no. That probability we are talking about. If 1 plus 1 is equal to 2, that is mathematics. While if any figure is near to 1, adds something which is near to 1, then together they will not be exactly 2, but it will be near to the 2. So that is the statistics. And in statistics, we'll see the various examples which thing we are using where. So first we'll talk about Z test, where we are using this, right? And then we'll also talk about chi-square test. We'll also talk about t-test, where to be it is to be utilized, and f-test. Once we go through this, then probably we can go to some other tests. So these are the main thing to be discussed initially. Now, suppose we need to, if you take any example, in that example there could be either uh, there could be a variable which could be quantifiable and from which you can find out mean, mode, median like this, and other variable from categorical variable from where you can find out the percentage. So first you need to decide your variable is of which type. So for example, we have a variable from which we can find out a mean, and we can have variable from where we can find out proportion. This file, if you save it, most of the 80 to 90% will fall in this category. Now in this case, first where you can find out the mean. So few examples like hemoglobin, you can say the height, you can say the weight, etc. Where you can find a proportion, for example, gender, male or female, or caste, or religion, or disease present or absent, diabetic, non-diabetic, hypertensive, non-hypertensive, or person admitted to the ward A or B, like this, or rural area or urban area. In this, you can find out proportion. So once you are clear about this, then things becomes much easier. So if a question is asked to you, for example, that there are two population in which we want to compare hemoglobin of two population, then you will be using standard error of difference between two mean. So the examples will be three types. When you want to compare sample with population, or you want to compare between two population, or sometimes it happens that you compare an and individual with population. I will give example of each category so that it becomes easier to understand. So first example, where you want to compare individual with population. When you compare individual with the population, usually we do not consider this cell because out of 100 population, you are picking up, let's say there are four kind of caste are there and there are 100 people and you are taking up one individual and you want to say whether this person belongs to this population or not. So such thing we are not examining individual with a population in case of proportion. Let's say that in a particular population there are 75 male and 25 female, and you are taking an individual whether it's a female or male, and then you can say if you ask a question whether this individual belongs to this population or not, so that question is usually not examined. So but if there are 100 individuals, we know their hemoglobin level, and a one person with a particular hemoglobin level, we can ask the question whether this person belonging to this population or not. In such case, it will be a standard deviation is used over here. We'll write standard deviation. We'll also understand how we are using this standard deviation. We'll not go exact calculation of it, but how we are using it. That we'll be considering. So, in taking an example, let's say mean hemoglobin level of a group is 10 gram with standard deviation of 1.5 gram, and we have around 90 individuals, right? In this case, if a person having 15 gram hemoglobin, 15 gram hemoglobin, and the question is usually what is the likelihood that this person belong to this group of 90 individuals whose hemoglobin level is 10 gram, mean hemoglobin, and standard deviation 1.5. So answer is like this. What is the likelihood the person belonging to 15 gram belongs to this group? So we can answer two ways. The distance between individual and the mean. Individuals is 15 gram, mean is 10 gram. So distance between 15 gram and 10 gram is 5 gram. So that 5 gram is double than the standard deviation. Double two standard deviation is 3. So what we write z is equal to mean minus observation or observation minus mean. We are taking as an absolute value 10 gram divided by SD. So this will be 15 gram. In a simple sense, this 15 gram is how much away from 10 gram? It is 5 gram away. In terms of standard deviation, it is more than 2 standard deviation away. Because if you look at the range, you double the standard deviation, it will be 3. So the range will be 7 gram to 13 gram. So 95% of individuals, of this 90 individuals, 95% will lie between 7 to 13. So in this case, Z is equal to something more than 3 point something, right? 3.2 or something like that. So here you can say that Z is more than 2, Z is more than 2 standard deviation away. So probability that this person belongs to this group is less than 95%, less than 0.05, less than 5%. Probability that this person belongs to group is less than 5%, less than 0.05, because the 7 to 13, 95% belongs to this group. So more than 13 and less than 7, both will be covered in 5% zone. So probability that 15 gram individual belong to this population is less than 0.05. That means this test of significance tells us that most likely this person is outside the group. In other way, it is significantly different from the group. Or you can use the word it is not by chance. 15 gram hemoglobin is not by chance. That person might have some different kind of the habits, different kind of lifestyle, etc. So, if you have any question, you can interrupt me. What other things you should be understanding that P less than zero point zero 0.05, it means significant. It also means not by chance. And if P is more than 0.05 or equal to 0.05 or equal to, it means that it is not significant. Why? Because it comes into 95% zone. So we say not significant. Other word which we are using is by chance. And this we say that we reject null hypothesis. We reject null hypothesis. And here we say that we accept null hypothesis. So this is how we move ahead. You can interrupt me if there is any question. So this is one thing. Now, in this case, let's say that we want to find out how many population will have hemoglobin level between 11 to 12.5. If the same question is we are asking the same example, that how many will have hemoglobin level between 11 to 12.5, then what do you do in that case? You find out Z for 11 also, find out Z for 12.5 also, and from Z table, you find out area under the curve. N area for 12.5, right? From that, remove the area for 11. And whatever is remaining, that will be the area under the curve. That is the number of person in terms of unity. So you can multiply by 100. So you will get a percentage. And then you will be able to find how many people will be between 11 to 12.5. So you need to look at the Z table, which we learned in previous session. So this is also an advantage, right, of using standard deviation. Now, let us take another examples. Dr. Panuganti, you are clear about using individual with a population?
Yes, sir.
Yeah.
Yes, sir. I'm clear, sir.
So, yeah, well, now we want to compare sample with the population. When we compare sample with the population, we have two questions in the mind. Based on sample, we find out what are the population parameters. Suppose we have mean hemoglobin level of the sample. So based on that, we can find out mean hemoglobin level of the population. Otherwise, we can also find out if a population mean is there, sample mean is also there, then we can find out whether the sample is representative of population or not, or whether this sample belongs to the population or not. That we are finding out. With this test, we are going for standard error of mean. Standard error of mean. This test we are going to use when we want to compare sample with the population. But instead of hemoglobin, if you want to find out, for example, based on a sample about the population, characteristic like this, how many people are male, how many people female in this population based on a sample, if you want to find out, then we are using standard error of proportion. And also, suppose out of your medicine ward, you have treated 1,000 patients, indoor patients, and we want to find out how many got cured, how many were not cured. That if you want to find out, then we can take a sample. Based on the sample of 100 individuals, based on that we can tell whether what will be the result in your total population. So this is possible. So standard error of mean and standard of proportion, both we need to understand like this. First, let's talk about standard of mean. We have population of 40,000 population, and we are taking a sample of 400 individuals. Now, population mean we do not know. Let's continue with hemoglobin. Population hemoglobin we are not knowing. But sample mean hemoglobin we know it. Sample mean hemoglobin level is 11.2 and standard deviation is 0.8. We'll not calculate over here because we have already done it, but just to recapitulate. Now, when we want to talk about population hemoglobin, based on this, we'll find out standard error of mean. What does it mean? That when we want to talk about population of 40,000 based on 400, because we are talking based on sample, there will be sampling error. When this sampling error is standardized, it is known as standard error of mean. How do we find standard of mean? We find out by SD upon root n, or we say the root S square upon n. That's what we say. Once we find out that, then population mean belongs to sample mean plus minus 2 standard error. This is how we can talk about the population mean. Or if population mean is given, suppose it is given as a 13 gram, and we want to find out whether this population belongs to sample or not, or whether this sample is representative of this population or not. Sample belongs to population or not, or sample is representative of this population or not. If you want to find out that, then again we can do 13 minus 11.2 divided by standard error of mean, and that will give you the Z. So you'll be able to find out whether this sample belongs to population or not. Similarly, if you need to find out proportion, same way, population is 40,000 and we don't know the proportion of people sick and healthy at given point of time. We are taking 400 sample. We know that at a particular point of time, 20% were sick. And we want to find out how many percent in the population, how many percent of the population will be sick at present. Then this population proportion 20% plus minus, we are supposed to do two standard error of proportion. And standard error of proportion is equal to root PQ upon N. We have P, that means 20% to 80%, and N is 400. So that will be standard error of proportion. So 20% plus minus 2 standard error will give you the range of sick people in the population. This is a utilization of standard proportion to find out population proportion based on sample proportion. But at the same time, suppose figure is given that 30% population is sick. That data we have. But the sample which is done, it is 20%. Now, whether the sample chosen was biased or not, that if you want to find out, then you need to find out Z. Z is nothing but the distance between two proportion, population proportion minus sample proportion, and this is to be divided by standard error proportion. Basically, standard proportion will tell up to two standard error. Error can occur by chance. Standard of proportion. This is what we can find out. And if Z is more than 2, we can say it is statistically significant and the sample which was taken was a biased sample. And if Z is less than 2, we can say this much difference can have occurred by chance. And how do we find standard proportion? Standard proportion is equal to root PQ upon N, right? This is how we can apply Z test in this case. So standard of mean, standard of proportion to be utilized when you're comparing sample with the population. As a test of significance, it is known as Z test. It will find whether the difference between population sample is significant or not. Now, when you want to compare the difference between two population, if it is a mean, then you use standard of difference between two means, standard of difference between two mean. But when it's a question of proportion, you use standard of difference between two proportion. It's simple. If I give you example, in one group of 800 people, there's a mean hemoglobin level is 10.5 gram with a standard deviation of 2.3. And another group, there is a 1,000 people and who are vegetarian diet, their mean hemoglobin level is 11.2 and the standard deviation is 2.1. Now, this difference between 800 and 1,000 people of hemoglobin level 10.5 and 11.2 is significant different or not? When we compare two population, essentially we are comparing two sample and based on that we are talking about the population. So this difference, so again z test will be applicable over here and we say the z is equal to x1 bar minus x2 bar, mean between two samples. It is the mean of two samples. Their differences and we divide it by standard error of difference between two mean. And that standard of difference between two mean, if you want to calculate, we calculate by is equal to root SD1 square upon N1 plus SD2 square upon N2. This is how we find out. And if Z is more than 2, we say that there is a significant difference between two populations. If Z is less than 2, we say it is not significant. Similarly, when we want to talk about the proportion, at that time, we compare two proportions in terms of standard of difference between two proportion. Here it will be percentage. Here 30% people are taking medicine for one or other ailment, while in this case, 12% people are taking medication for one or other ailments. Now, this 18% difference is significant or not? For that, we find out standard error of difference between two proportion, which you can measure by is equal to root P1 Q1 upon N1 plus P2 Q2 upon N2. This standard of difference between two proportion you apply over here, P1 minus P2 divided by standard of difference between two proportion. If Z is more than 2, then it is significant. If Z is less than 2, not significant. This is how we have five kind of tests and five kind of example we have taken. But now there are other things where we need to use other examples also. So that we have talked about five types of Z test. But now, when in this case proportion, sample with population and sample to population, but when we have three or more populations to be covered, to be compared, or three or more samples to be compared, at that time we cannot use standard of difference to mean, and there is nothing like standard of difference between three means. So we are using ANOVA over here, analysis of variance. F test is used over here, and in this case, we are using chi-square test. Chi-square test. So now the question is, where do we use the t-test? Generally, standard error of difference between two mean we are using where sample size is more than 30. But if sample size is less than 30, we are using t-test. And in this t-test also, if observation are paired, like before and after in the same individuals, or for each individual, we have taken a control, the similar control, Then if the samples are paired, we are going to use paired t-test. But if we have not the paired the samples, right? Then we are going to use unpaired t-test. So when there is a two population, but the sample size less than 30, we are using t-test. If sample is more than 30, there also we can use t-test, but then z-test also gives a good results. So it can also be used. Now, this is about usual. Most of the tests will be applicable over here and you will get the answer. But when did talk about here only about one variable over here, one variable over here. And we compared individual with the population, sample with the population, two population, and then three or more population. But if variable are more, what do we do? Which test we are using at that time? So in that case, suppose we have two variables, height and weight. We want to compare between these two in let's say 100 individuals. So we make a regression analysis and we want to find out correlation coefficient. So if these two variables are there, in case of variables are proportions, right? Like the food taken or not, a banana taken or not, or milk taken or not, or a person took the roti or not. There are certain so many variables, right? In this case, and then person becomes sick or not, ill or not. Person become ill or not, like this. In this case, where you have a multivariate, multiple variables are there, you can use multivariate analysis. And that is the cup of the tea of, or I think, say, or you can say cup of milk for the statistician to do that, the high level analysis. It can be a logistic regression analysis to find out each component, how much this component is contributing, right? So this is something about the test of significance. So if you have any question, we'll address to that. Else, I'll be talking, revising a little bit in 5-10 minutes about non-parametric tests, which can be utilized when. Any question?
No, sir.
So yeah, I'm moving
No.
ahead for a non-parametric test
Yes,
where
sir.
it should be applied, right? So going to epidemiology, it will be quick analysis. This Kruskal-Wallis test, just recapitulate where we are using. Only that part we will be taking. Rest of the examples calculation is already there. AP info is also giving you. And this is an example where you have four groups and you want to compare means of that. So if it is more than 30 data, we should have used F test. But because the data is very small, the ANOVA F test we cannot use over here. And that's why we are using Kruskal-Wallis test. There are four series and each series have something from where you can find out the mean, right? So Kruskal-Wallis test is used when there are multiple population, multiple samples to compare and where you can find out the mean. So this is Kruskal-Wallis test. Then Mann-Whitney test. In this case, you have a very small data and There is nothing like a mean you need to find. It's a rank is given between the two samples. Samples are very small. Not only that, it is not from where you need to find out the mean, but it is somewhere from where only the rank is given between two groups. In this case, you are going to use man, Whitney, or you test. You are going to use, right? These are two groups. But if you move further, where you have positive and negative results, you have a data where you have positive and negative results, improvement or not improvement. And again, it is a rank which is given or rating given plus improved, not improved like this. In such a data, your T test, F test, those tests are not going to work. And that's why you are going to use sign rank test, Wilcoxon sign rank test, where when or 10 patient or 15 patient you have or 5 patient you have, and there is a both the way, patient may improve or may deteriorate, and you are making a sign minus or plus, at that time Wilcoxon sign rank test will be utilized. Then there is something other than this also, where you want to compare judgment between two examiner, judgment between teacher and student. At that time, you are going to use kappa test. So it is like this. Is a rate given by one examiner, rate given by another examiner. Both yes, no are there, and the kappa will be there. If kappa is 1, it is 100% agreement. If kappa is near to 0, is disagreement. Is a minus 1, is total disagreement, like this. And you need to just put a figure over here, and then your answer will be that this is a kappa test. Then there is a something like you have huge population. You want to say the whole Bombay city you have, and you want to find out only you want to take only 19 individuals matching you for a particular things, age group or so, and you ask them and to find out whether the coverage is this much or not. It will not tell you what is the coverage, but it will tell you whether this much coverage is there or not. So at that time, the LQS method is used, and you are already given this file whereby you need to just write down your name of units, name of wards, name of school, name of colleges, or name of the areas, etc. And the numbers in that particular unit you need to write down over here. Once you replace this thing automatically, when you write down samples, I usually keep it 19. And this will give you a sample size from where you are supposed to take a sample. This one will be there. You need to use only this F. Forget this D, forget this E. You need to count only from F. F gives you from which village or where you need to take a sample. From this 645 individuals, or you might be taking children or students of particular characteristic, you pick up randomly one individual. That's all. Similarly, if you pick up 19 individual and find out how many of them were vaccinated, how many of them not vaccinated like this, then from rule or table you can find out whether that much population is covered or not. This is how this loss quality assessment is used. You can use the same calculation for cluster sampling also. In that cluster sampling, you write 40 over here, that's all. And from each cluster, instead of taking one, you try to take 6 individuals of your characteristic. Then it will be 6 from each cluster will make you 240 individuals. This is how this same the table which is given to you is a template you can utilize for cluster sampling also. The result you can read from decision rule table, which is so simple that if you have taken 19 individuals, example is given, out of 19, if 7 are, for example, says that we are not vaccinated, that means you can say that 50%, 50%, right? 7 is a less than 50% in 19. So what you can say over here, the coverage will not be more than 50%. Suppose if 12 individuals are vaccinated, right? So you can say that the coverage is not beyond 75%. This is how you are utilizing this table. It will not tell you that this is a percentage. It will tell you it is not beyond this. So these table lot sampling is not to find out percentage, but it will tell you whether this percentage could be there or not, whether this is true or not. Bombay municipality says that 75% people are covered, and yours says that out of 19, only 12 are there. So you can say that it is not beyond 75%, like this. So this is how this table is to be utilized. Right? So this is the rule table how you utilize this. And these are the already test of significance file is given to you and we talk about this. So now we can take if you have any specific questions or we can end any time. Sir, you have any questions now?
No, sir.
So shall we take go for 30th session or we close down over here itself?
Okay.
So we go for 13th session only if you have any doubt or we'll end the series or the our session over here. But
Yep.
anytime you can uh, attend the next few sessions, you can connect with us for your research, data analysis, AP info, etc. Right?
This is survival analysis, sir.
Huh?
Survival analysis. Can we do a few words?
About AP info analysis
Uh, Usually we interactive with those things, sir. In
with
general
the
club,
data analysis.
we will be discussing those cases, sir.
Yeah, see, uh, I think shall we take up this AP info analysis in next session? Should we? Or you are so you know the AP info analysis very well.
I don't know, not much.
So next session will take about only AP info analysis, so that at least you should know how to do the analysis with AP info. You have installed AP info software,
Yes, sir. Yes, sir.
then it will be not difficult. And if by chance if data is ready on Tuesday, you can share the Excel file. We'll do the analysis on that because you have also taken the suppose data is ready for that blood pressure, right? So
Sir.
whether there is a concordance or not, there is a correlation between these two or not. That also we can go for the go for with the analysis with AP info, and there's inter-observer, intra-observer, inter-instrument, intra-instrument, all this
Yes,
kind
sir.
of error.
I'm
Let's
collecting, sir.
discuss that.
I'm just
Yeah.
collecting that. I'm just collecting the data, sir.
Even
That's
if you
just,
collect some data, we can add more data, and then we try to do how you are going to do analysis. So Tuesday, shall we meet?
other members,
Hmm?
other members, sir.
Others are member not that you are only interested in individual. So I'm talking to you only.
Sir.
So if you write in a group that Tuesday we would like to learn something, we'll taking on a Tuesday, or else we'll not we close down over here only, right? So
Okay.
any query in future, anytime,
Yes, sir.
I would love to
Certainly,
do
sir.
that.
Certainly,
Right.
sir. I will.
Oh, thanks. Bye. Thank you.